Hello everyone, today I am going to deliver a lecture on influence line of rudder beam. Here is the topics will be covered is first of all I will provide a lecture on influence line of girder with floor beam, influence line of truss, this is the truss, this is the girder with floor beam and force uh, maximum force and design force diagram for moving load. So I'll not if I will not get enough time, then I will skip this. I will explain later. Okay, so let's start. Influence line of the girder. So okay, here is a influence line of the girder. You can see here. Before going to here, I'm just showing some video picture here. Sorry. Okay, whatever. So we can see here the two support is given here. This is the girder, and this is the floor beam. This is the floor beam is given here, and this is the stringer, and this is the slab. This is also even it is for bridges, and you can see here the influence line here. The all the girder. This is the girder, and this is the we have been seen, and the floor beam and a stringer. And you can see here the girder, and the deck slab is here, and this is the car is moving on the road. Okay, we've been seeing another picture which is we can see the train hinge load, and this is the deck slab, and then stringer, and then cross girder, and the top of the cord, and webinar, and bottom of the cord. And this is the load is phenomena distributed like this way. If we see here another bridges, the truck is moving from left to right as a steel truss, we can see. Okay, so these are the main basic in the practical we have been we will found this way. Okay, let's start for girder. Here is the girder, and we can see another FR, that means floor beam reaction. Okay, so let's start array. Here is the array. We can divide it array at a we going in upward in 1 unit, and then there is a support, that's why it will be 0, and it will be like this way. And now we'll calculate the similar triangle for this portion. As we know, this is the 1, how much, 6, 12, 8, 8, 12, so it will be 20, this will be 20, 40, 46. So I will calculate the triangle of the calculation. So 46 is gone to 1. So if you calculate if you want to calculate this portion, then we are calculating we assume the similar triangle is here. How much? It will be 40. This is a 20 and 20. This is the 40 length. So 40, how much will be x? So x will be 0.85. So in this way we are we also comparing this triangle and this triangle and this triangle also. So and we'll get the all values here. I'll not seeing again and again as I'm watching at a time. And RB, how will get the RB? This is the point of RB where forwarding 1 unit 1, and there is a we have been seeing the support, that's why the support will be 0, and this is the free and the moving and the influence side will be like this. And the floor beam R2, this is the floor beam R2. How will calculate if it is providing 1 unit 1, this is the support, you can say. So support will be 0 as we know. So the line will be like this for floor beam 1. Okay, so we can see this is the floor beam 1. The influence lines will be like this. And another floor beam R3. So this is the R3. If we calculate, if we want to draw the floor beam R3, so where it will go on the upward one in this way, and this will be 0 as we know. This is the support and this is the free end, so it will be gone there. So like this. So we have been calculating this here, floor beam R3. And floor beam R4, we have been seeing how we calculate the floor beam R4. If we change the color again, and where it will be upward is 1, so this is the 0, it will be 0, so it will be like this. Okay, so this will be, it will be like this. And floor beam 5, how we calculate the floor beam 5. This is the floor beam. We will know there is a 2 point as we have been found here, floor beam 5. So there is a 2 point. So two girder, two stranger will be gone upward. So first of all, this stranger will be like this, and second of all, this stranger will be like this. As there is a support, so this will be like this. Okay, so support will be 0 as we know, so this will be like this. And floor beam 6, I will calculate the floor beam 6. This is the floor beam. So if we turn is 1 watt in 1 unit on in upward, then it will be like this. So that's why it will be like this. Okay, so now we'll calculate the find B2C. This is the girder here. We have to calculate the shear B23. So if we see here how will 2 and 3, so if we will calculate in this portion. So B23, after if you want to B23, then we have to take in moment shear. We have to take in the shear. So we have been seeing this is the reaction is gone upward, so RA is upward. So and another one floor beam is gone the downward. So RA minus floor beam 2. This is the our equation. So if we now if we get the equation RA minus floor beam 2, then we have to firstly draw the RA. So at first I am drawing the RA, so I'm just changing color. So but you have to, at first you have to find out the equation. So what will be the equation? This is the equation. If you get the equation, then RA minus floor beam, then you are drawing the RA. Otherwise, if you equation got the another, if you take the this equation is RB minus something like this, then you have to draw the another one. Otherwise, you don't need to RB. I am not drawing the RB in previous line because I don't need. I have not any equation. Okay, so this is the array. How we'll get array? We've been taking upward in 1 unit 1, and we've been seeing here. This is the support. That's why it will be 0. So we are passing all things here. And if we compare the triangle is here, this calculating, I've already shown how to calculate the value here. This is for similar triangle. So I'm just using this similar triangle equation as this is the one. Then we will find out this value for comparing the triangle. This will be 0.875, 0.51, 0.43, 0.26, and it will also the comparing the similar triangle, which is 0.35. And second one, this is the floor beam 2 as per our equation, floor beam 2. So this is the floor beam 2. How will calculate floor beam 2? This is the floor beam. So if we do in upward, the stringer will be act like this, as this is the another support. So it will be like this. So I'm just drawing here. This will be like this. The support will be must be 0, 0. So this point is also 1, and we just comparing the similar triangle as I have been shown. I will calculate, and it will be 1.5, and it will also will compare the similar triangle and found 0.6. How will calculate the this I have been shown how we will calculate the similar triangle and found the result. Okay, so now we are getting the all results. So then now we'll draw the floor share 2 3, this point 2 3. So array, this is the array value we have been found 1 and minus 1.5, so it will be minus 0.5. And similarly 0.875 minus 1, as we have been know array minus floor beam, this is the array and this is the floor beam. So 0.875 minus 1, it will be 0.125. And again array have been known 0.61, and floor beam is 0, that's why 0.61 minus 0, it will be 0.6, positive 0.6. And then same way we are taking the 0.443 and the minus 0.67, it will be 1 1. And it will be going the breakdown because of there is a floor beam we can see here, that's why it will be breakdown only array, we're taking the only array 0.43. And this another one array minus floor beam 2.26, and there is no value, that's why it will be 0.26, and it will be 0 as array. There is no influence line of RB because the equation is there. If we put the equation at 0, then it will be 0. And last one we've been seen array is minus 0.43, it will be 0.35, it will be 0.35. So these are the value I will draw the B23 here. So in the similarly I will calculate the M3. So if we calculate the M3, so at first MB, this would be MB, so I will calculate MB. So at first I have to take the moment here, RA into this distance, it will be 18, and floor beam 2 into 12. Here is a floor beam 2 into 12. So this portion may be B point. So we are taking the moment point, this point. So RA into 12 plus 6, this will be distance is 18. So this is the 18 minus floor beam into 12. So floor beam into 12. So that's why it will be this equation. So now we are putting this below RA. This point is 0.15. 0.15 into 18 minus floor beam 2. Here is the floor beam 2, which is 1.5. 1.5 into 12. Then it will found 0. And for second point, this is the second point. I will get RA into 18. RA will have been known 0.87. And into 18 and minus floor beam 2, here is the floor beam 2, which is given the 1, and to 12, then it will be found 3.75, this point. I will calculate this below, this equation. We just using this equation, putting the value of this equation, array of this point, how much it will be 0.61 into 18 minus floor beam 2, where is the floor beam 2, this point have been found minus 0.67 into 12, then it will be found 15.75. And how will get the 7.75? We just using the value of array. Here we have been seen 0.43 into 18, then it will be 0.43 into 7.74. This is the only for, as we have been seen, this is the floor drop the floor beam. In this way we will draw the reaction. So let's see another example. Here we have to calculate MC. I will calculate MC. This is the point of C. So we are taking the moment with respect to the C. We can take in the left section, or we can take in the right section. So we have been before starting here we need to draw here if the moment is taking the left section the equation, if the moment the left section equation taking the left section the moment the value will be positive and moment diagram will be also positive. If the moment is taking in the left section the moment value is positive, then moment diagram also positive. So there is no problem for left section. On the other hand, if we taking the right section, if the moment value is positive, then the moment diagram will be negative. This is the vice versa. Is the opposite thing. If the moment diagram is right and the moment value is negative, then moment diagram also positive. So it will be a far difference when we are taking the moment in right section, as we have been seen in first math, where this is the first math we have been taking moment and share in the left section. This is the section of left. If we are taking the right section, then it will be value will be changed. So now see, I will change the value. Here the moment C at right segment. We are considering right segment, this segment. We are not considering this segment, left segment. Okay, so if we consider the right segment, then our value will be positive value will be take the negative diagram, and negative value will be positive diagram. How we get? So at first I am taking the moment which RB minus 6. This is the RB and we are taking here. So the distance is 6 is given in question. 6 and floor beam is here. Floor beam RB 5. This is the floor beam RB R for floor beam 5. How much? 6 plus 16. It will be floor beam 6 is given. Sorry, this is the floor beam. First floor beam is 16, and floor beam 2 6 into 16. It will be 22. It will be floor beam 6. It will be floor beam 6, and it is the floor beam 5. Okay, so after the getting this equation, now we have to draw three type of diagram, which is array. At first I am doing to array, and then we have to draw another which is floor beam 5. This is the floor beam 5. So we have to draw the floor beam 5, position of 5. And last one we have to draw the floor beam 6. This is the floor beam 6. This is the floor beam 6 only. So let's draw at first RB 6. So we are taking the RB 6 is here on RB 6. This is the point of RB. I'm just erasing all things. Okay, so this is the RB, and I'm taking 1 unit right here, and then this is the point of support, that's why it will be 0. Then we are drawing here. And floor beam 5, this is the position of 5, and just this is the 6. Okay, I'm just forgetting to marking here. So floor beam 5, it will be upward, and this will be 0 and this will be 0. I will draw this way and this way. So these are the floor beam 5. And floor beam 6, this is the floor beam 6. It will be just upward. I'm just changing color here. It will be upward and go down. This is the floor beam 5. This is the floor beam. Okay, so as this is the we are taking the all the value is same as. Now we are putting this value here. So RB6 at first, if we calculate here 13.9, I will get this is the minus RB into 6. As we know, yes, RB is given 1.35 into 6 plus floor beam 5. This is the floor beam 5 into 6, 0 into 6, it will be 0. And floor beam 6 into 22, floor beam 6 into floor beam 6, we know the 1 into 22, and we are will found positive 13.5, positive 13.5. So we are not writing as positive 13.5, where rather than we are writing the minus negative 13.5. Why? Because when we're taking the segment of right side, this is the right side of point C, then the value will be changed, and the positive value will be negative diagram, and negative value will be positive diagram. So it been found the positive value, so the value diagram will be negative. So in this way we're putting the this point, the second point value, which is rb equal to 6, or 1 into 6, and floor beam 5 into 6. Floor beam 5 is 1 into 6, and floor beam into 6 into 22, this is the 0, and it will be found the 0. In the same way we'll putting the all this value in this equation, and found this diagram. Okay, so remember that how will when we see that this is the gap, then we'll take the only floor beam on the only reaction, on only reaction. Okay, how will get the 3.42. This is the 3.42. How will get this is the calculation we have been seen here, where rb into minus 6, rb is given floor beam into 6, which rb is we have been known here only 0.57 into 6, it will be 3.42. This is the 3.2. Okay, let's see another example here. How we'll calculate b3. This is the b3. We've been seen here what b3 into 4. So 3 into 4. So we have been taking here the shear. What will be RA minus floor beam 2 into floor beam 3. So we're taking the second left segment. So RA, this is the positive, and this is the negative. Floor beam 2 and floor beam 3 is negative. So RA minus floor beam 2 and floor beam 3. This is the equation. Now we have to draw the RA. Not only we are drawing here RB, RC. So we're now we're doing here RA. So reaction of RA is doing here, and is here. And how will get the value? It is it will be compared with similar triangle. Then it will get the value. And then second one will draw the floor beam R2. So this is the floor beam R2 we have been drawing here, and this is the floor beam we have been. If we go is upward 1 Newton, then it will be like this. It will be like this. And then floor beam R3. I will get the R3. This is the R3. I'm changing the color. If we it is upward, then it will be 0, and it will be also 0 as the reaction is giving. So it will be like this. Okay. So these are the diagram. Floor beam R3. So after this finding this drawing this, then we will putting all this value here, and drawing this type of finding this type of value. Okay, so second one we have been seeing M3. I will get the M3. This is the 3 point we have been seeing here. We are taking also left segment RA into 16. I'm just erasing this here. So if we calculate the moment in here, this point, then it will be force into perpendicular distance, which is RA into 10 into 6, which is 16. So RA into 16 and 4 beam 2 into 10. So only 4 beam into 10. So these are the equation. So now we have to draw RA. RA is already drawn here, so we don't need to again, and floor beam 2. Here the floor beam 2, so we don't need to again that drawing. So after finding this diagram, now we are putting all the value in this equation, and finding I will find this diagram. Okay, so now we'll see in M3. I will calculate the M3. This is the M3. So if we calculate the right section, then if we get we will get the floor beam 12. Here is the floor beam 6, floor beam 5 into 12. Sorry, now floor beam 5 into 12, 6 into 6 into 12, and floor beam 2 into 20, so 6 into 6 plus 8. So we are considering this right subsection, not that, sorry for that. So in this way we'll find this equation, but we are putting this equation, then we found the value of 0.36, but it will be, when we will draw, then the value will be positive value will be negative, and negative value will be negative value will be positive diagram, as we've been already said that, as we are considering the right side. Okay, so this is the last math example of girder. Here I will calculate the BAB left. So BAB, this is BAB left side, it is RA into floor beam C. RA into floor beam C. Okay, this is the C, floor beam C. You can see here RA is giving here, and floor beam C is this is the floor beam C. So now we'll draw RA into floor beam C. So RA is we're drawing here RA as usual. RA is reaction is here, and floor beam C, this is the C we have been seeing here. So I will calculate the floor beam C. So if we doing here upward, so this is not C, I'm sorry for that, this is the C as you've been seeing here. So this point will be 0, so like this way, as the support is always 0. So the diagram will be like this. Okay, now we are just putting all this value of this diagram. From this diagram, then the influence line will be like this. MB, how will calculate the MB? This is the point of B. If you calculate the moment from here, so you've been seen RA into 20, so RA into 20, and another floor beam RA equal to 20. This is the floor beam RA equal to also 20. So we are doing RA and floor beam RA. So there is I have already RA diagram. This is the RA, but I have not floor beam RA. This is the floor beam RA. So I will draw. I will draw here, and this is the support. It will be 0 like this. So it will be like this. So after getting this, and we'll putting all this, we're putting this value from this equation, and found drawing this like this way. Okay, so influence line is Girders in depth. Now we'll show the influence line of trusses. Okay, so let's see here the influence line of truss. Okay, influence line of the girder. These are the basic we have been found Professor Dr. Ansar. We have been seeing here the influence line of the girder and floor. He is also giving some sample calculation here. If you need, you can use this and use that also here. Okay, so let's see here the influence line of the truss. Here the influence line of the truss we can draw from here. We can see here the truss is given here, as we've been already seeing the practically here. We can see the here the actual design of the actual application of the trusses, as the vehicle is moving from left to right. Okay, let's see. Okay, so we can see here the given here. So now we will calculate the floor. What we will calculate? Find FAB. Okay, this is the FAB. How will calculate FAB? For getting the FAB, this is the FAB. We are taking the joint method at this is the joint method A. So So we're taking this point here, and we see here RA, and the FAB is given here, FAS here, and FRB is given here. So RA is upward, and floor beam reaction 1, this is the floor beam reaction 1, is going to the downward, and another one we have been seen for AS. This is the AS. AS is gone on the right side, and FEB is given. We have been shown the dimension is given 4 into 9. That means this is the 4 feet, and height is given also 5 into 12 into 5. So as we have been seen, this is the 3, and this is the 4. As we have been know the slope, this is the 3 and this is the 4. Now we can calculate FAB in easily. When we taking the FY, then we will take the 4 by 3. This is the 4 by 3, and 4 by 3 we have been taking here for RA into 4 by 3, this portion, and floor beam R1, and in this way we've been seen for 5 by 4 floor beam RA1 and RA. So we just to draw RA and floor beam 1. So this is the RA, this is the reaction of RA influence line, and floor beam 1, this is the floor beam 1. So after getting this floor beam 1, we can draw the diagram influence line of RA. For taking this equation, we just using this equation and putting this value, and found 0.0, and second point 0.937, this is 0.937, and third point is 0.602, 0.302, and 0, and it will be like this. Okay, so second one we've been seeing FAS. This is the F for FAS joint method at 0. As we have been found FAS plus FAB into 3 by 5, FAB into 3 by 5, 3 by 5, as we have been taking x-axis, and found this equation. I'm just changing the equation, which is FAS into minus AB into 0.36. So if we know the AB value, this is the AB, just putting the all this value F into 0.36, then it will be 0.0. At the first point is from 0, and second point 53625, this is the 53625, and 0.375, 0.375, and 0.10, 0.1825, 0.1825, and 0. So this will be our second diagram. And third, we can see in FBT. Here is FBS, FBT here. So if we get the FBT, then we have to take the moment is here. So we are taking moment point C here. So we have been found this equation. This is our FBT, the final equation. You can see in RA floor beam 1. So RA we have been already drawn, floor beam 1 we have been drawn, and floor beam 2. This we need to floor beam 2, and FAS here already FAS we have been taking here. So after the putting this value, then we will found this diagram. Okay, so let's see another example. Find the E1 L1. So this is the E1 L1. So we need to calculate for E1 L1. For joint method, we are using joint method here, and this is a joint method. So new L1 U1 and L2 U2 floor beam R1 L U2 U2. If we calculate RY, summation of RY, then we'll found FE1 L1 equal to floor beam 1 only. So this is the floor beam 1. So we're just drawing there, then it will be finished. And second one we have been seen here, U2 L2. So this is the U2 and this is the L2, this format. So we are taking U2 L2 for section method. We are cutting the section here. This is the section we have been already cutting here. So it will be like this. It will be like this. Now we are taking the only summation of Ry. Then how we'll get R naught. This is the R naught or RF floor beam R naught. This is the floor beam R naught in opposite direction, and floor beam Ry. This is the floor beam Ry. This is the floor beam Ry. And then floor beam R2. This is the floor beam R2. This is the floor beam R2. And positive U2 Y2 equal to 0. After this calculation, we have been found this equation. So we have to draw RA. So RA already this is the RA. The diagram we have been drawn RA. And second one is a floor. Second one is floor beam R naught. This is the floor beam R naught. The diagram we have been drawn. And third one, floor beam R1. This is the floor beam R1 is already drawn, so we don't need to draw that one. And the last one, floor beam R2. This is the floor beam R2. So we are just putting drawing here the floor beam R2 with respect to now all the after the putting all these below, then we will getting F2 L2. This F2 L2. How we get this below? We just putting R minus R1. This is the minus R1 is 1. This below we have been putting here, and floor beam R2. This one floor beam R2. This below, and floor beam R1. This is the floor beam R1 point. This below, and floor beam R2 also are not this one, and floor beam R2. And putting here the first point we have been 0, and second point 0.17, and third point is 0.33, 0.33, and 0.50. So after putting all these below from equation, putting this equation, then we will find this diagram or this below. Okay, in the similarly we've been taking U2 U3 L3. So this is the U3 and L3 this here. So I will calculate U3 L3 from join method. We're taking here only join method, and found U3 L3 equal to 0. Okay, so so this is the 0 force member. That's why there will be no influence diagram. So now we are doing U2 L2. So this is the U1 U2. This is the flow diagram. So for taking this diagram, we are taking the left section summation of L2, and a reaction not equal to 6. So we're known all the dimension 6 into 3. So we're taking the moment from here, 3 into 3 into 6. This is the 6, and floor beam not equal to also 6. This is the first floor beam not equal to 6, and floor beam 1 equal to 3. So this is the floor beam 1. We're taking moment from here. That's why it will be 3 into 3 into 6. All the distance is given here, so it will be 3 into 3 into 6, only 3, and F2 U2 equal to 4. So we know the F2 equal to F2 U2 is 4 is given in here, and putting finding this equation, and we are finding this equation here. So we have to draw R naught, as we have already drawn here the R naught. And second one, we have to floor beam R naught. We have to do floor beam R naught. So where no the floor beam R naught is already drawn, so we don't need. And third one is floor beam R1. So floor beam R1, here is the floor beam R1 already drawn. After finding this this diagram and floor beam R1, uh, floor beam R not ds. So putting this equation or this diagram, we're just putting um, all the value here. Then we'll found first point will be 0, this will be 0, second point sorry, and second point will be point minus point 0.5, minus 5, minus 1, and third point 0.75. In this way you can calculating here. So this will be our below. Okay, so I have this influence line of the trusses completed. Now we'll see the how we'll calculate the maximum force and design force diagram on moving. Okay, let's see. So you can use the influence line of the truss. You can see here Professor Dr. Ittiba Anams are also written here. You can follow this. Now we can see here maximum force diagram of moving load. Okay, let's see here. Okay, I'm just take a time. Okay, so we calculate the maximum moment and shear. This is our diagram we've been seen here, as we can see and previously. So after getting this influence line, I'm just finding influence line here. So how to calculate the maximum moment? Okay, this will be half. This is the trigonal. We're just taking the trigonal formula, as we know, half into length into height. So these are the triangular. Half into length is found and height is 5, and it will be boxes. It will be maximum value, dead load plus live load, and minus will be this point, the second section. This is the second section. Half into length is 5 and height is 5. So it will be boxes. So after the calculation, we have been found two type of 63.75 and 7.75. So when we'll see the maximum value 60.75, then we'll use the dead load plus live load, or maximum value will be used here. And when we see the smaller number, then we will multiply with only dead load. Why? Because this is the rules. We can see another example here. We can see here the first segment is here. So half into length is 5 into height is 2, and we are digging here box. And second portion we've been seen here, half into length is 5 and 3.5. And after the calculating here, we have been found this value is 15. On the other hand, we have been found this value is 8.75. So 15 is max. That's why we are using in this box is dead load plus live load. On the other hand, we have been seen is 8.75. It will be used only dead load, because this is the less value. That's why we are using less number. On the other hand, it is the bigger value. That's why it will be used bigger number. Okay, so let's see another example here. In the same way we've been seeing, this is the trigonal. So we'll take half into length into height is taken 2. On the other hand, we've been seeing another segment here. Half into length is 5 and height is 3.35. It will be take here. So after calculating here, we have been found 26.25. On the other hand, we have been seen here calculating this value, we have been found only 5. So we are using only dead load here, as we have been taking the small number, and the bigger number we have been found, the maximum value we have been found. That's why we will use in maximum dead load plus live load. So we can see here the maximum value, where there is a maximum value, then we will use dead load plus live load. Otherwise, where there is only minimum value, there will be only dead load. Okay, let's see another example. Here is an example. Calculate the maximum reaction and maximum shear force reaction at A, shear force B, and maximum bending moment B and D, and given beam dead load is given 1.5 and moving load is given 1.5. Moment load is live load. Okay, so let's see Rmax. How we'll calculate the Rmax. We've been seen here half. At first we're drawing the influence line here, RA. This is the RA, and this will be 0 as the at the reaction. Then we're taking here. So this is our RA influence line. So I will calculate the maximum RA. So just erasing. This is the two section. So first section is here, and second section we have been seeing this. Okay, so now calculating the first section here. This will be half and length. This is the length 7.5 and 7.5. This is the 15, and height is a 1. Then it will be box. We will use 2.5. Why? 2.5 is given dead load plus live load. Dead load is given 1.5 and live load is 1. But we will not using here immediately. And this portion, and taking this portion half. This is the half, and to length is given 5. This is the 5, and height is 0.33, and this is the section. It will be box. After calculating, we will find this is the less value, and after calculating we will find the maximum value. It will be 7 into it will be 7, and on the other hand it will be might be 2 into 5 into 4 it will be 3. So that's why it will be 3 into less value, and it will be 7 into bigger value, which is dead load plus live load, which is 2.5. So that's why we are taking the boxes as we have been seen in previously here. The boxes will be calculate the maximum value with the maximum number, and minimum value will be minimum number. Okay, in this way we can calculate B just left. We have been taking the moment B just left here, and the diagram influence line will be like this. B just right. We've been taking the B just right. The diagram will be we are using insulting the ruler support, and it will be like this. So I will calculate MB, maximum MB. So we're taking the moment is here, the influence line is here, so it will be like this and like this. So the influence line will be like this. So I will calculate half into length. Length is 5 is given here, and height is 5, and we are taking this is the box. So this is as we have been seeing, this is the only one segment. That's why we are taking the dead load plus live load and together. Okay, B just we are taking here the B just. We've been taking this is the B just. I will calculate the B just left. Okay, let's see. This is the two segment. We have already drawn B just influence line. This is the influence line B just. So this is the influence line B just. So there is the two triangle. This is the first triangle. Half. This is the half into length. How will length? The 15. We have been seen here. 7.5 into 7.5. It will be 15, and 1 is given is here. So this will be box. Will not writing first. And second we have been taking the second segment is here. This is the second segment. So half into length is 5. How is length? This is the length, and height 3.3. This is the 3.3, and this will be boxes. As we are taking here, this will be 7. So 7 will be box, and another if we deduct is here 2.5, it will be 2.5 into box. So 7 will be box and 2.5 box. So we've been seeing the 7 is a more number, So that's why we are taking the dead load plus live load is more 2.5, and we are taking the 2 into 2.5. 2.5 is only dead load, so we've been taking only less number. Yeah, as this is the we've been seeing the dead load plus live load 2.5 is taken here. As it is taking all the value is downward, that's why we are taking 2.5, as we have been already shown here. Okay, let's see here the we just right. So maximum I will get half into 1. Sorry, it will be not, it is the triangle we have been seeing. It is not triangle, it is the rectangle. So 5 into 1, 5 into 1, 5 is length, 1 is height, and 2.5 is a dead load plus live load, and it will be 12.5 kg. And last one we have been seen here, MD. This is the last one calculation. Please uh, take it, draw your attention. This is the last calculation, I will not seeing again. So I will calculate the MD. At first we have to draw the influence line of MD. This is the influence line. So if we calculate here, so then the line will be like this. So these are the line we have been drawing here. After the calculation, we are putting this value a plus b into a divided by a plus b, which is 3.75. Okay, so this is the first. Now this there is a two segment we have been seeing. This is the triangle segment, and second one we have been seeing. This is the another triangle segment. So let's see the first segment. So this is the half, as a triangle half into length 7.5 into 3.5. This is the first portion, 7.5, and 3.5 into 2. 2 is, we've been seeing the two triangle, that's why we are multiplying 2, and this will be boxes. We don't know which value we will use. If we get the maximum value, then we will use the dead load plus live load. If we get the less value, then we will use the only dead load. Okay, so let's see the second portion. This is the second portion we can see here. This is the half, and length is we can see is a 5. This is the 5, and 2.5 is the value is 5, and this will be boxes, as we have been seen here. The dead load plus live load is previously. So after this we calculating, we have been found here. This is this portion will be maximum value. That's why we will using 2.5, which is dead load plus live load. On the other hand, we have been seen here only dead load, because there is a less value. Less value will be only live load, dead load, and maximum value will be we are multiplying with dead load plus live load. Okay, I hope that you can understood. If you can see here, Professor Dr. a slide here, you can clarify here. We can see here the maximum positive value for BL. So BL will been found 1. 1 is half. 1 is unit weight, and half into 15 into length, and 3.335 into 2 into 2.5 is given here. Dead load 1.5 and live load 1 is total dead load plus live load 2.5, and found this way. And right section will be also like this, and MD is also like that. So you can also draw the shear force diagram and bending moment diagram after the getting this all this value. Okay, I hope that the lecture is ended. If you have any confusion, then let me know. I hope I can try to solve your problem also. Thank you everyone for your patience. Thank you again.